So, hello everybody, I'm Jacques Dubourdieu. I'm a winemaker in the Bordeaux region and also a general manager of Denis Dubourdieu Domaines. We had the chance to be a pilot in this program. So it was really interesting for us to be part of this adventure. And I will present you our group of family estates. So Denis Dubourdieu Domaines is a group of 6 family estates in the south of the Bordeaux vineyard. So it's a company about 135 hectares, and we vinify in 3 different places. It's a production about 500,000 bottles per year. So we are in the medium size, we will say, in the Bordeaux landscape. We are an historical family in this region. So we also own 2 classified estates in 3 different appellations, so Côte de Bordeaux, Grape, and Sauternes. So it's a medium company, as I told you, so about 40 people, 100% family owned. So here you can see all the history of the family. So my great grandfather Georges Dubourdieu bought Doisiden, which is the most historical estate based in Barsac, Sauternes. My grandfather Pierre Dubourdieu runs the estate during 60 years. My father, Professor Denis Dubourdieu, was also involved in research and enology. He was a professor of enology at the Bordeaux University. Unfortunately, he passed away in 2016. So we continue the family business with my brother since 10 years now, and we were very interested to continue research and innovation to understand better how to make a better wine in an environment always more preserved. So we try since 10 years, for 10 years now, to have a very sustainable viticulture. So of course, no irrigation in Bordeaux. There is no irrigation allowed, no herbicide, no antibotrytis. We also are certified ISO 14000 wine, HVE, haute valeur environnementale, bee friendly. We also analyze chemicals residue in every bottle of wine. So we are quite involved in all the sustainability and about viticulture, especially at quite a big scale, because I mean we are not a big company, but we are not small. It's not about 3 hectares. So we try in this family business to make efforts every year. And finally, to be part of this program was a wonderful opportunity for us to continue our efforts. So the context is we need more and more precision in our viticulture. We also need more efficiency and a better environment protection. So we, as I told you before, we run 5 estates in 5 different villages with 300 different plots, different soil, different weather condition, of course, different grapes. So we need more information and more precise information. So our expectation are we are expecting a different improvement. First of all, phenology. So what is exactly, at what step are we considering maturity? To be more precise in terms of spraying phytosanitary products at the right time with the right quantity. And also we need more precision considering all these steps to adapt ourselves to the different weather condition and especially the weather risk. So mainly spring frost, wind gust, and hail. Yield estimation is also another important expectation for us. So how to reach the optimal yield, enough for financial profitability and not too much to maintain the quality level. So it's also a way to anticipate the volume before the harvest and to anticipate market evolution, to anticipate our offer with our client. So the yield estimation is quite important, and we need more and more precision and ideally the information earlier and earlier. Health of the vine. So vines are part of our capital. For some reason, we have some grapes quite strong that we can keep for 50, 60, 70 years. And we have also some grapes like Sauvignon Blanc, for example, which are a lot more fragile. We have mainly one disease called esca, among others. And we need more data and more analysis on this phenomenon, which is quite unfortunately increasing. So we need to evaluate the problem more precisely, and we need to know more about its evolution by a convenient way. So it's a big expectation we have on this point, because unfortunately the esca is increasing. Information on about vigor, of course. So vigor in viticulture is quite ambivalent, because we don't need too much vigor because it's a problem in terms of quality, but not enough vigor, it's also a problem, because it means there is some problem in terms of viticulture. So to have a precise vision in terms of vigor for each plot can help to choose the right plants, the right rootstock, but also the right fertilization policy and the right way to grow vineyard. So to be able to map the vigor is a very important criteria for us, and it's not that easy manually to have that kind of information.
Okay, thank you, Jean-Jacques. So you have presented us some questions, some issues that arise for the viticulture, and in our lab we try to find some answers to this question within the IOF 2020 project. So the first answer was based on fixed sensors placed in the vineyards for different objectives, such as vigor estimation. On the left side of the slide, you can see the scheme of our sensor and the first prototype of it. In fact, the sensor is based on a low-cost multispectral camera, a low-cost computer, and the computer manages the power and the lighting system in order to provide one image each night, which is processed on board to compute, for instance, the vigor. And then it sends the result of the vigor estimation to the farm management software using a network such as the Laboratoire network. And all the system is enclosed in a weatherproof housing with a motorized sliding protective shutter, just in order to avoid the destruction of the sensor when you use a sprayer, for instance. So in the next slide, you will see some results we obtained with the sensor. So fortunately, if you can see the video on the left, you can see the growing each night of the vegetation of the vine. And on the right part, you can see the evolution of the curve, which is an estimation of the leaf area index. And you can see that at the end of the growing stage, we go to the maximum value, and then it's decreasing a little bit because we have some vine shoots that are decaying. And you can see the decaying of these vine shoots clearly on the curve also. And on the next slide, if the video wasn't working well, maybe you did not see what I said, but you can see the first picture, one of the first pictures at the beginning of the curve. where there is very few leaves. And then you can see on the right side, some at the end of the growing stage, when the shoot are all and the leaves are all gross and some of them decaying, and you can see the corresponding value on the curve. So this is the kind of example of the result we obtain, and the prototype we have provided in order to compute the vigor estimation. Another example of answer we provided was the design of a mobile sensor dedicated to both vigor estimation and yield estimation. So once again, on the left part, you have the scheme which describes how the device work, and you can see a prototype also with two sensors with the lighting system on a tractor. So this sensor is a high-performance mobile sensor. It is based on an industrial camera with a high-power flash, an outboard computer, and of course a GPS for the localization, and all in a dust-proof housing. We put 2 units per tractor in order to monitor simultaneously both sides of the vines. And the tractor goes to its usual speed, up to, for instance, 6 kilometers per hour. And we take 1 image per vine. That means probably 2 or 3 images each second.
5 minutes missing, Christian.
Yes, thank you. The images are not currently processed on board, but it's still to be done. It's a problem we will have to address. So some kind of results we obtain with this sensor. You can see on the left the berry detection. It's not yet the yield estimation, but we are able to compute on each plot on each vine the berry detection, the number of berry which have been detected, and you can see on 2 different plots. One where the results are very heterogeneous, and the second one where they are much more homogeneous in a matter of number of berry per vines. So it can help to understand how the yield is done on each plot. Some future works. So we are currently working and have already obtained some interesting results regarding phenology. You have, for instance, it's here 4 examples of phenology: fruit set, pea-sized berries, cluster closure, and half veraison, for instance. And we have some algorithm that should provide this estimation of this stage. Another future work, which is already ongoing, it's the disease detection. For instance, on the left, you have an example of an algorithm that which detects symptoms of SK, which is a grape wine trunk disease. And on the right, it's quite more difficult because it's very small symptoms. It's the case of downy mildew, and you can see some true detection and some error we still have to solve in order to detect as early as possible the downy mildew. Another future work is yield estimation. You have seen that we are able to count the visible berry on an image, but not yet to extrapolate that to the yield estimation. The extrapolation is still unresolved, and it's an ongoing project in another European project that is beginning. We have also some missing vines to detect, and the absence of vegetation is not always the sign of missing wine. So we are trying to use both summer and winter images to solve this problem as accurately as possible. So this was some kind of example of future works. Jean-Jacques, for the conclusion, maybe?